Hello everyone, welcome to the next episode in the GameAudio Tech Tips. Today we're going to be looking at creating an audio spline in Unreal Engine. So what I've got here is I've got a little image that I've drawn some bad lines on to give some kind of context to what a spline is and the use case of a spline. So typically you'll probably use a spline to support audio for an area that isn't necessarily volumetric. So what I mean by that is this example here. There's a tree line on the left and a body of water on the right side here. And let's just assume for now that they're out of bounds, so the listener cannot enter or go next to this area. So you can see here on the left side of the tree line, we're kind of following the path because in this example, let's just say that the camera would have a block and it wouldn't be able to enter that zone. So rather than mark up every single tree or have multiple emitters following that tree line, a good example of a spline is to have a single emitter that would follow the listener or the character along that path, and the same for the water as well. Rather than place many sounds along a volume of water, we can have one emitter that would follow again. So you can see I've drawn these lines on the floor here just to represent like the angle of this path where the shape. But really the splines wouldn't be on the floor probably. They would probably be higher up. And they might be doing something like checking the height of the listener and matching that kind of Z. Well, let's say Z because I'm using terms of Unreal here. Yeah, so just bear that in mind. There's also use cases of using splines as what we would call a closed loop. So right now, this example is literally just a line. But if it was a circle, that would be a closed loop. And there are cases when you'd want that to happen. For example, a tree line still. We might want to draw sounds around a tree line, but not care about it being a volume. So it doesn't have to have many axes. It doesn't need to move along like a room. It will just have a single kind of axis on it. Or again, like a river body. Very good use of a spline is a closed loop on a river, so that as you go into the region of that river, the emitter would stay on the spline, and then maybe move to the character whilst you're in that closed loop, and then again attach back to the spline when you leave it. So those two examples of good use cases of a spline, and we will look at exploring those in the video. And I've got this other little image that I've made in Paint. So if you think about this green circle here as the listener, or I like to call it the target, so it could be the character, it could be the listener, it could be something else. You can see here there's these blue circles as well, which represent, in this case, let's say for example, this middle one here, that could be the closest point on the spline to our target, and we might want to move a sound across that. Things I've done on projects in the past is not just worry about the closest point, but also other points as well. So for example, splines typically have a value of, let's say the start of a spline here is 0 and the end of a spline here is 1. So that would be based on time along the spline. So for example, let's say we're 0.5 here, we might want to push our emitters plus or minus 0.1 to just give a bit of width on that. So this is a nice example of having different configurations of splines. So we might only want one sound that follows us. We might want a spread of sounds which follow us, and again would track along our position, but just give a bit more width. You can kind of get the width with spread, but this gives like a physical width as well, which is nice. Some things you might want to think about if you do this sort of thing. We're not going to cover this in the video because that's a bit more advanced, but some things you might want to think about is if you do something like this, what happens to the emitters when they get to the edge of a spline. So for example, when this one on the right gets to time 1, let's say, does the audio emitter stop moving at that point? Or does that one stay there, then the middle one can still push into it as well? So yeah, just it presents more challenges when you get more advanced. But yeah, they're very powerful tools that are very useful to use in the game. So we're going to make a simple audio spline today, because it is quite a big topic that comes up in GameAudio tech stuff, like how to do a spline, and it's, you know, they are quite simple, and we're going to make, yeah, like I said, we're going to make a simple one that's to get you started, and then obviously then you can do whatever you want to level it up from there. That's kind of the aim of this channel, is getting people the first steps into doing something, so that then they can own it and then think about ways to make it better. Because, you know, it's important to kind of encourage that kind of process and not just give the answers out, because, you know, the splines are so dynamic, they can be used in so many different ways. Another use case of a spline as well is tracking like an RTPC. Let's say your level is maybe a linear, maybe not, and you want to do something with the mix as you progress that level. There you go. A spline is a perfect way of saying, like, during this path of this level, I want this RTPC to do something like, I don't know, change the mix or do something cool in another thing of the game, like, you know. So yeah, very powerful tools, and we will look at building one now. Okay, welcome back. We are in Unreal Engine now. I'm not sure if I mentioned this in a previous video, but we're using a project called Lyra, which is just like an Epic's project that they give out, and it's just a nice way to just get up and running with a set of characters and some basic controls. Typically you can click play and go into like one of the arenas and shoot things. For my demos that I'm doing, I'm just doing it in the main kind of starting area, just because it's easy for me. It's just already working. There are some limitations to Lyra, like some functions don't exist from that are part of base and Rio. I think they've changed some of the code there, so, you know, but it's probably unlikely you would run into those. Like there's some things to do with like the editor, like some of the, like, are you checking if you're in the editor or not versus running the game. I think some of those things are a bit different with Lyra, but yeah. So when we get to the construction script later, there will be some not ideal ways that it works because of that, but that's fine. We can work around it. So as always, we're going to put our stuff into a folder so it's nice and neat. These are obviously folders from the previous videos that we've covered, so if you haven't looked at things like tick by distance, which actually work really well with splines, do check them out, because yeah, it's really cool. So let's get started. So we are going to create an actor class, audio spline. Let's do this. Something else that we tend to do as well is, although we are in Unreal Engine here, and although I'm very familiar with Wise, I don't usually create Wise components, Wise game objects. I tend to just draw debug or create a sphere, which I'm going to do now, because that just keeps it generic as possible, so that you might not be using Unreal, you might be using some proprietary engine or Unity or whatever. So this topic is you can do it in any engine you want. That's why I try to not use physical like audio connector things wherever I can. Right, okay, so we want to add a spline actor, yeah? Spline component. Here we go. And it's just nice if we just give it a little bit of let's just give that 500 here. So there's 2 spline points on our little thing now. And then let's create a spline point here as well. Let's say 250. So this is going to start talking about what a spline does. If I bend this, look, we can see that there's some kind of shape that we can start to form here, which in this case, the emitter is going to move along as we move along with the target in the level. And we will get onto that in a moment. And then we're going to make a sphere, just for the sake of me showing where the emitter might be. If you don't have to do the sphere, it should be an emitter. But just for visualization here, we're going to use a sphere. Okay, so one thing we want to care about is, in this example, we're going to look at the player character. So get player character. And on the introduction video, I spoke about using something called the target, because again, it might not be the player, it might be the camera, or it might be the listener. But in this case, because it's easier to see where the character is, we're going to use, we're only going to care about the character. And we want to get the actor location. And we care about this location later on. So we are going to promote that to a variable. And we're going to call it character location. Okay. Now, another thing that we care about is our kind of spline to the location, target location link. So in that case, we're going to find closest, find location closest to world location for our spline component here. And the location that we're bothered about is the character location. Okay, and we're going to set the coordinate space to world. And let's promote the variable again. And we're going to call this closest location. Okay, I'll just keep looking up because I'm referencing my notes. And what we will do next is get our sphere, and we want to set location. I just cannot type set world location. And we're going to set it, in this case, to the closest location. Okay. Awesome. So now, let's just get our spline. Give it a bit of rotation there. And let's just extend the length of that point. When it's in your level, by the way, let's say we want to add an extra point in there. We can right click this line, add a spline point. And then now there's another point for us to have our shape. Okay. Right. Let's press play and see what happens here. Okay, so there's our sphere. And you can see the sphere is tracking our position on the spline. Depending on how aggressive your tangents are with the bend, the object might jump. So it's good to kind of have them as smooth as you can. Or find ways, again, this is getting a bit more advanced, but if it's trying to jump too far, is maybe you have a lerp function that sets the closest point to that. Let's say we're here now, and then we go here really quickly. We can set that closest point variable still, but just have our lerp of moving it, so it's just a bit more smoother. You can definitely do things like that if you want. We're not going to worry about that just yet though. So this is cool, but we don't have any context of where the spline is. So let's do that. And one thing as well that we've just seen is we've got a runtime error. It can't find the character. That's because on tick we are asking for our character location, our player character here, which during the first tick of Lyra is not valid because it gets created after. So as we mentioned in a previous video, it's usually good to validate your blue kind of nodes, your actual actor components. And the spline may or may not need to validate that because the spline is part of this blueprint. It's good practice too, but we won't be doing that just for now. So yeah, let's work to now visualize this spline to help us out understanding where it is in the game. Because in editor we can see it, but when we're in the game we can't. So yeah, let's think about ways to visualize that now. Okay, so to visualize it then, we're going to go to the construction script. So this is something that essentially runs like whenever the spline has a setting that needs to be applied. And it's quite powerful for us to do things here with it. We'll see what I mean by that. So let's now think about what we need. So our spline has multiple points on it, and we need to visualize those points. So what we're going to do is we're just going to loop over how many points there are, and we're going to create a mesh along each of those points, essentially. So let's do a loop. Actually, no, first we need to get spline points, get number of spline points, and we're going to loop over those, just like that. And what we want to do is we want to add a spline mesh. Add spline mesh component. Let's take a manual attachment, and we want to make sure that it's valid, just in case we're trying to add these and then for some reason it's not adding them, and then we're trying to reference them later on. Next, we want to set the forward axis. There we go. Sorry, you need to come out of here and do that. Just like that. And we want to set static mesh, because again we're having meshes represent our spline. And we may or may not want to set material. Set material. There we go. That's fine. And lastly, we want to run set start and end. Okay. Cool. Awesome, awesome. So for each of our index, we want to get location and tangent. That point. Okay. Let's set the world and start tangent, and we're going to copy this and put it here as well. Same setup, but this time what we're going to do is we're going to add +1. And I can show you that in a moment while we're doing that. So in editor now, actually, we can see that it just looks like it did before. The construction script is doing something, but it's not visualizing anything because we've not set a mesh. So let's now add a mesh. So the first thing I'd recommend is using some sort of like cylinder. This vertical thing seems fine. So now let's see what that looks like. Nothing. Okay. There we go. So this isn't really cool for us because it's not representing much useful shape of the spline. So what we would need to do in this case is change our axis around and just have a play with that and just see kind of how it wants to respond. I think Z is the right one. So yeah, Z now is obviously looking a little bit more, it's kind of representing our spline a lot better. The actual mesh doesn't really work for us. Cylinders are usually the kind of best shapes I'd recommend, but there's not really much going here. And then material, what we can do here is, if you just want to make it have a different color, so let's, for example, this color here. There you go. That looks much more nicer. That's kind of representing our spline quite nicely. It is quite thick, which may or may not be a problem. You can always change the actual this static mesh actor here. You can always go into there and change the actual properties of it if you want to do that. But for now, I think that serves us okay. And if I move the spline points, you can see now that it's still kind of representing our shape. When you start to get like these tangents happen, the consistency of it does fail a little bit. So just bear that in mind. There's probably better ways to visualize it and add in extra steps, but this is just a nice rough idea. You don't always need 100% accuracy on this kind of thing. So then, now let's get back to our spline. So yeah, okay, that's another thing. So in game look, we can see it now. So our little circle here. In fact, let's make that a bit bigger again. Our sphere, let's set that back to 1 because I reduced it earlier, didn't I? We can see now our little sphere. We can much easily represent like where it is along this this spline. So we know that it's working. Like we can already do something with this, and that's great. So now back to the event graph then. So what else might we want on this spline? I mean, we might want to do something with like an RGPC or something, or some kind of like distance parameter. So what we're going to do is, actually, before I do that, we are going to show the closed loop functionality of it. So if we go back to our spline and then click the actual spline component here, there's a closed loop feature there. So if I tick that, and then now grab this point here. Oops. We need to actually grab a spline point there. So you can see now our spline is a closed loop. So if you look at the shape here now, we can actually get in that point there. So now if I go into the spline, you can see it's following my position here. And then as I go in fact, it's blocking me. Sphere, collision. Never use custom other than for videos. Custom is bad. Cool. Oh, there's a Lyra thing happening there. So yeah, as I go into this area, let's call it the isn't spline. We can see that it's still trying to track us. It's not doing what I would want it to do, which is in this case go to our character. So that's what we're going to look at now, actually, before we look at the distance element to it. So the first thing we need to ask is the spline in a closed loop or not? So what I'd recommend is, after we understand the location, we need to now detect, are we in that bound? So let's look at that. So let's get our spline. And the way we're going to do this is by using our dot product. Now, character location and world. Okay. Now we are concerned about our closest location. Subtract by our character location. Okay. And then we want to find the dot product of that and the right vector. Because essentially what that might look like is, if you imagine our spline point is where my camera is now, the right vector to that is facing in to the other side of the spline, which means we now can understand that we are in the spline. I hope that makes sense. So again, if I'm on the other side, my forward vector is looking at that sphere in the background. My right vector is looking at the other side of the spline. So the dot product of it is going to be less than 0. That's just how we are going to identify or not if we're in the spline. So we're going to say, are we equal or less than 0? And what you can do is you can do something like branch, and then if we are branching, then we do something. If we're not, we're going to do something else. Because actually what we need to do is, if we are in the spline, we need to set a Boolean. And for example, like I say, if we are less than 0, we can say true. If we are not, we can say false. Branches are really useful, but unless you specifically need a branch to do other things than just a Boolean, and other things after that, I like to do just a select node instead. So what we're going to do here then is we're going to select what value to set. So we're setting is in spline. Now we need to select which one we want to choose. So spline. We need to get our spline, and we need to ask, is our spline a closed loop or not? Because if we go back to Unreal, if this is unchecked, we don't need to run the extra logic to say, are we a closed loop or not? We just need to set it to false all the time. So by using that as our wildcard, what we need to do is say, if our closed loop is true, we're going to select this. If it's not, then we're always going to be false. So again, that makes the select allows you to have a single line of readability rather than branching off, which is much easier to read. And because we're doing different locations now that we're concerned about, we need to actually have another variable introduced, which instead of the closest location now, we're going to have something called emitter location. And the reason for this is because if we are in the spline, we still need to know the closest location, because that's how we find our right vector, our right dot product. So then now when we move this sphere or emitter, we need to make sure that we have another variable where we want to move it to, which is going to be the emitter location. So we want to set our emitter location, and because we're now using this Boolean, this unlocks this for us. So again, rather than branch rather than branch, if it'll be in spline, branch true, set our emitter location to this, set it to that. We're just gonna again go back to the select node. Much more cleaner to use. So this is our wildcard. And if we are not a closed loop, our emitter always wants to be at the closest location. That's where we want it to move. If we are a closed loop, we want to move it to our character location. Because we are inside the spline. Sorry, not a closed loop, we are in the spline. If we are inside the spline, we want to set our emitter location to the character location. If we're not inside the spline, we want to set our emitter location to the closest location on the spline. Which means then we need to update our variable here to now be emitter location. And let's just make sure that this works before we do anything else. So our emitter is following us on the closest location. I'm now in the closed loop of the spline, and our emitter is now attached to the character. And I go away, and now it's unattached again. Cool. So next we care about something else. So we want to make another variable, and we're going to call this distance to closest location. Okay. So this is where we can do something like set an RTPC that we might care about, or some other value. So we are going to set this, and we are just going to get the distance from our character location. Distance to our emitter location. And the reason we're doing this is because when we set our emitter location from being in the spline, it's from the character location. And then when we're not in the spline, the emitter's back to the spline location. So our character will be at different positions to that. So this is a nice, reliable way of not needing to select a value. It's just always going to be this one that we're concerned with. And then, of course, we want to do another thing. We want a Boolean, and we want to start drawing some debug values so that we can check some things. So branch. And let's do a function called debug. Here. So inside our debug function, what are we concerned about? We want to draw string, and let's draw a line. I like to draw lines. Okay. Awesome. So we want to format text. I'm pretty sure I've shown format text. I think I say that in every video as well. It's just a nicer way of formatting text other than the append on the print string. So what we're concerned about is if I do these squiggly lines, these squiggly brackets, is in Spline. When you do this, you can see it gives you some inputs here, which is really cool. So you can, if you're using appends and you have to add pins and then you want to change the order of things, it becomes really a pain to like remove a pin, add a pin, swap it around, unplug everything. Whereas this way you can just change the order that you write them in, and then they will format that way when you're visualizing them, which is awesome. So what we can do as well is, because these are just squiggly brackets which take the input value, we can actually type distance equals squiggly distance, and then is in spline equals squiggly is in spline. Cool. And we are concerned about our Boolean value here and our distance value here. And let's give that a nice purple, which I like to always draw. And the location for that is going to always be our emitter location. And the line that we might want to draw, you don't have to draw a line, I just think it's nice to visualize it, is our character location and the emitter location. And again, let's do that as purple. And let's see then what this looks like. So I'm going to set this to true. What the hell is going on with that? Yeah, so now we can see them. We've got our nice little sphere that follows us, and our debug here is saying our distance to it. So this might set an RTPC, and then is in spline equals false. And then when we go into the spline, the distance is 0, and our is in spline is true. So the reason why the distance is important is because if the sound was on our listener, when we are attached, so now let's imagine that the sound is on the listener and it's in our head, so to speak, our distance is going to be 0. And that's important because at that point, that's when we want to do full spread on our sound, to make it sound like it is everywhere. And then as we move away from our spline, that distance value would then curve down our spread value. I've just gone into a different level now. So as we go further away, our spread will collapse, and then we can position our sound more accurately at a point in the world. Because if we are 1,000 units away and it's full spread, we're not going to understand the origin of that sound. Or if there's no spread, we can say like, okay, the sound is like specifically roughly there. Say roughly because you might want to have still some spread on there. Which is awesome. So yeah, that is the spline working. That is game ready pretty much. Like obviously it's not actually playing sounds. It's not actually playing sounds or anything like that. It's just the functionality of the now is there ready for you to do things like from here, set the RTPC from this, or do something here. The way that we have it as well is our sphere is part of the actor. Something you might want to think about is because we are tracking distance, we could do other things like if your attenuation range is, let's say, for example, 2,000 units or 2,000 units. If we are outside of attenuation range, maybe we destroy the emitter because we don't need it anymore. And then when you enter the distance of your attenuation, you spawn the emitter again as an optimization measure. So yeah, like I say, very powerful tools, and I just recommend following this tutorial and then leveling it up as you would like to from there. Cool. If there's any questions, obviously feel free. And again, if you think about our tick by distance function that we did before, do check that out and incorporate that into this, because that's a good example of using that tick by distance. Because again, when we are further away, when we're right next to it, we need to update very quickly. When we're further away, we might not care about the spline, the emitter following the spline at every frame. We might want to skip a frame or do 10 frames or something. Cool. Awesome. Have a nice day, everyone, and see you in the next one.